Hi everyone, I'm Jose Miguel. I'm a software engineer working here at Gramazio Kohler, starting in this project in Kumiki. First of all, I'm going to give you a brief explanation on the motivation on why we do this. So 280 billion US dollars or 280,000 million for Europeans. That's the amount of money that was lost or estimated to have lost in 2018 due to rewards caused by poor data and miscommunication. When asked to stakeholders about what was, or to the thinking, what was the main cause for this loss, they said these reasons. One of these is no common platform to share data. So essentially, right now, projects have to exchange data manually between architects and other stakeholders in the project. So much you might be wondering then, how is this even possible today? How is that this large number of money is being lost during these reworks? So let me give you a brief explanation as to what the current process for making a timber building is right now. First of all, we start with the architect. So they go onto Revit or any other BIM software and start drawing the building in 3D or in 2D. Then this building gets exported onto 2D plans, either by literally printing them into paper or as PDFs. And then the timber engineer has to manually redraw these plans again in another specialized software, in this case, CAD work. Of course, this takes time and can lead to some mistakes because there's some manual work done over again. But there's a reason for this manual work being exchanged in here. Mainly, the reason is that architects and engineers have to use a specialized software. So architects like to work with Revit, and timber engineers need to work with CAD work because they do different things. They are specialized programs. The other reason is that timber engineers tend to distrust the model from the architect because in Revit you can do things like put, I don't know, like angles of 89.99999 degrees, which is kind of annoying when you want to do this precisely so that it can be directly fed to the machine to plot it. So that's one of the reasons why they prefer, when we survey them, to do this manually by hand again. This could, in theory, be automated because with Revit and other software, you can export the WG files and then import it into CAD work. The problem is that these files only contain geometry. You lost the information as to this is a wall, this is a ceiling, this is a slab, etc. And this is not a problem that only happens with timber. This also happens to other constructors like HVAC. So with this in mind, our goal is to automate the data exchange. We want to get rid of this manual process of redrawing the plans again when we move to a different software. This is what Kumiki does. So the main idea is, say we have these two programs again, we have Revit and we have CAD work. And in Revit, we have this native object, which is a Revit wall, with windows, doors, whatever. And we want to be able to move with this software, with Kumiki, that wall into the native object from CAD work, which in this case is a panel. Not just that, but we also want to come back. We want to convert that CAD work panel into a native Revit wall. And we don't want to stick with these two softwares. We also want to integrate other types of software like ArchiCAD, which is also widely used in Europe. This is a demo of the software. So in here, I'm sure most of you are already familiar with this UI. This is Revit. Here on the right, we have our software. So the architect, to push this to CAD work, we'll have to select the elements to share, then click on the push button, and we will get a report. Then we move to the CAD work side, to the timber engineer side. We have a similar UI in here to the right. We click on pull to fetch the changes. That will give us a report. And lastly, we will get the final building in here. As you can see, it's the same objects, but being converted to the native representation inside CAD work, which in this case are panels. Just for a brief technical explanation on how this works. Again, we have these Revit objects, which are the Revit wall, floors, family instances, which is the way that Revit represents columns and beams. And what we do is we convert those to an internal representation, which we call Kumiki elements, or K element for short. So that's why in here we have hierarchical organization of the elements. We will have K special element, which is where we use, as an example, some of the COMPAS core classes, so a frame to position the element in a 3D space. And then we will have several different elements like K-wall, K-pin, K-floor, in which we use also COMPAS timber to represent this information internally. This gives us the advantage to be able to exchange this data with any software. Because now that we have an internal representation, we just need to do the mappings between Revit and Kumiki, CADWare and Kumiki, ArchiCAD and Kumiki. And then from this internal representation, we can move to any other software that supports this implementation. Lastly, I want to say that this is collaborative work. So we have a team here at Grammatio Color at ETH, but we also work with industry partners like CADWork and ERNE. And we are looking forward to meet other partners. So if you're interested in trying this, just reach to us or Matthias. That's everything I have for you today. Thanks for your attention. And if you have questions, I'll gladly answer them at the end of the session. Thanks.